Hi guys, I just want to go over a couple more problems with you dealing with concavity. Sort of showing you a couple weird things or different things that might happen. Let me find. Why would I be prepared when I start the video? Silly Mrs. Willenbrock. Okay, so a little bit more with concavity, couple special cases. Let's say, I'm going to have to think fast for this. Hang on, guys. Like, seriously, Mrs. Willenbrock? About. Okay. So let's say our function, our original function is 1/12 x to the fourth minus x cubed plus 9/2 x squared plus 3x plus 1. Woo! That's a crazy function. Okay. And we're going to go directly to the concavity analysis. So we're going to go to the second derivative. Well, we can't go directly to the second derivative. We need to make the first derivative first. So f prime is going to end up being 1/3 when I take the 4 times the 1/12 x cubed minus 3x squared plus 9x plus 3. And so my second derivative is going to become x squared minus 6x plus 9. Now, this is what I was sort of trying to figure out. I had to go backwards a little bit. I wanted to come up with an example where when you get your second derivative and you set your second derivative equal to 0 to get your critical values, you get a double root. Okay. When you get a double root, looking at concavity, chances are it's not a concavity change. Okay. If we do our analysis of f double prime, on our number line around x equals 3, something plugged in less than 3, like a 0, would make both of my factors negative, and it would make my whole function positive. Something plugged in bigger than 3, like a 5, would make both factors positive, would make the whole thing positive. And so I would get my function is concave up from negative infinity to 3 and 3 to infinity, which is possible. No point of inflection. It's possible to have one type of concavity with no point of inflection. Okay. And this can happen a couple different ways. This is the first way. And it makes sense. Well, we're going to need to get to a point where we get a double root from f double prime. Okay. You might not know that's going to happen in the beginning. But once you get here, you go, oh, okay, this is sort of potentially a weird scenario. Yeah. The second possibility, my little boy's upstairs making noises. Oh, he's excited because we're going on an airplane today. Yes, I am making this video Wednesday morning. So, f of x equals negative 5x squared plus 7x minus 2. Once again, if we're going for description of concavity, we got to go first derivative, second derivative, and then you're like, well, what the heck am I supposed to do now? I can't make that equal 0 because it's not, doesn't have an x in it. It's just negative 10. This is actually the best kind. This is the easiest kind. No critical values. F double prime is negative from everywhere. If I was going to do a number line here, I'd be like, not even, no, there's no critical value here. I can't put any critical value on the number line. I just have a big number line, and f double prime is always negative. It's always negative 10. So I would say my function f is concave. Are you filling in the blank? Down everywhere. Once again, no point of inflection. And if we go back for a minute, that makes sense. An upside down parabola is nothing but concave down. It's just one big frowny concave down thing. One type of concavity, no point of inflection. Give me a second. Ooh. You're like, what's she doing? What's she doing? She's going rogue. You know I do this sometimes. I don't remember. Fourth x cubed plus 9 halves x squared. Okay, I know there was other stuff. I don't remember what it was, like plus 3x minus 1. Actually, it doesn't matter because that part doesn't change the concavity. This guy is weird. This is the one we were looking at before. And it does... It looks just like a regular parabola. Can we see it? I don't know if we're going to be able to see it. I don't know. I was going to see if we have some kind of like visual clue about that weirdness at 3. I'm going to need a lot more graph to... Okay. Kind of see how this side does this, but then this side kind of goes kind of off to the side. It's not a beautiful parabola-ish looking thing. That's that inflection. Well, that's not an inflection point. That kind of makes it sort of go weird. It's kind of not really, it doesn't really have the symmetry that we would have expected. It doesn't look really nice. It's kind of, this side's kind of different than this side. Okay. Not a real good, no, we don't really have a good visual of, because it's not an inflection point. Okay. It's not an inflection point, so we don't really see it maybe doing anything weird on the graph. It's just concave up on both sides. Okay. Hope that helps you with the last couple problems on your assignment.